Solar wind and radiation are responsible for stripping the Martian atmosphere, transforming Mars from a planet that could have supported life billions of years ago into a frigid desert world. We've determined that most of the gas ever present in the Mars atmosphere has been lost to space. About 65% of the argon that was ever in the atmosphere has been lost to space. In fact, Earth's atmospheric gas is being lost to space today, and the atmosphere is stripped away. The present analysis uses measurements of today's atmosphere for the first estimate of how much gas was lost through time. Liquid water, essential for life, is not stable on Mars's surface today because the atmosphere is too cold and thin to support it. However, evidence, such as features resembling dry riverbeds and minerals that only form in the presence of liquid water, indicates the ancient Martian climate was much different, warm enough for water to flow on the surface for extended periods. This discovery is a significant step toward unraveling the mystery of Mars's past environments. In a broader context, this information teaches us about the processes that can change a planet's habitability over time. There are many ways a planet can lose some of its atmosphere. For example, chemical reactions can lock gas away in surface rocks, or an atmosphere can be eroded by radiation and a stellar wind from a planet's parent star. The new result reveals that solar wind and radiation were responsible for most of the atmospheric loss on Mars, and the depletion was enough to transform the Martian climate. The solar wind is a thin stream of electrically conducting gas constantly blowing out from the surface of the sun. The early sun had far more intense ultraviolet radiation and solar wind, so atmospheric loss by these processes was likely much greater in Mars's history. According to the team, these processes may have been the dominant ones controlling the planet's climate and habitability. It's possible microbial life could have existed at the surface early in Mars's history. As the planet cooled off and dried up, any life could have been driven underground or forced into rare surface oases. A team of scientists got the new result by measuring the atmospheric abundance of two different isotopes of argon gas. Isotopes are atoms of the same element with different masses. Since the lighter of the two isotopes escapes to space more readily, it will leave the gas remaining behind, enriched in the heavier isotope. The team used the relative abundance of the two isotopes measured in the upper atmosphere and at the surface to estimate the fraction of the atmospheric gas that has been lost to space. As a noble gas, argon cannot react chemically, so it cannot be sequestered in rocks. The only process that can remove noble gases into space is a physical process called sputtering by the solar wind. In sputtering, ions picked up by the solar wind can impact Mars at high speeds and physically knock atmospheric gas into space. The team tracked argon because it can be removed only by sputtering. Once they determined the amount of argon lost by sputtering, they could use this information to determine the sputtering loss of other atoms and molecules, including carbon dioxide. CO2 is of interest because it is the major constituent of Mars's atmosphere and because it's an efficient greenhouse gas that can retain heat and warm the planet. We determined that the majority of the planet's CO2 was also lost to space by sputtering. There are other processes that can remove CO2, so this gives the minimum amount of CO2 that's been lost to space. These estimates were done using data from the Martian upper atmosphere. The analysis included measurements from the Martian surface made by SAM, NASA's sample analysis at Mars instrument on board the Curiosity rover. The combined measurements enable a better determination of how much Martian argon has been lost to space over billions of years. Using measurements from both platforms points to the value of having multiple missions that make complementary measurements. So yes, solar wind and radiation are responsible for stripping the Martian atmosphere, making it uninhabitable and probably uncolonizable. And by the way, if we have the ability to create a new atmosphere on a new planet, why the hell don't we just fix our own and carry on with our lives? Never thought of that, have you?